listening to here is a short experimental composition I wrote using Python for harpist Danielle Kuntz. You can check out the full performance of Resonance Study on Danielle's channel by clicking the link in the upper right, or in the video description. What was fun about this piece was that I tried to model the idiosyncrasies of harp technique, such as pedal and hand positions, as Python classes. It was an interesting challenge to try to express explicitly these limitations and capabilities that I would normally work with intuitively. What follows is an edited conversation Danielle and I had about how this piece came to be and the things that we learned along the way. It's definitely a bit longer than a typical video on this channel, so I invite you to treat it like a podcast. Find a comfy spot and kick back with a warm drink. It's always a privilege to work with talented performers, and I hope this is the first of many such collaborations, both with Danielle and with other performers adventurous enough to explore this kind of thing.
So I am curious about what your general process for composing, how did you approach it? What was your starting point?
Yeah, so I knew that I was trying to write a piece for harp. And so because the instrumentation was kind of the focus, I decided to approach it in terms of like modeling the harp in code. Part of the motivation for that was, I knew I was working with you and I've seen some of your videos on different aspects of harp technique. And so as I was watching those videos, I was just thinking, well, this is a good in here. I should try to somehow model the harp in code. And I can show you a little bit of what that code looks like.
Yeah.
So in particular, let's share my screen right here. This is the code right here. And you got several different files here, handposition.py, pedal.py, and then, classically harp demo 2, harp demo 3, harp demo 4, harp demo 5. So, harp demo 5, this is the actual piece itself. And you can see that it's importing from hand position and pedal. And this is actually what I started with, was creating a Python class for a harp hand position and another Python class for a harp pedal position. And I wasn't 100% sure what I was going to do with these. I just wanted to create the tool so that whatever I was writing had harp hand positions in mind and had harp pedal positions in mind. That was kind of the idea. So maybe I can ask you, what actually matters in terms of hand position on the harp?
So probably the most important thing is that there's only 4 fingers available per hand. And that's a big distinction from piano, where you're usually going to be playing with 5 fingers. So making sure that the groupings only include 4 notes. I would say the second most important thing is the overall spacing, or what we could call the wingspan between, the first and the last note, making sure that's not too large of an interval, and then the individual spacings between the fingers.
Yeah. Okay. So check this out. So this is the init method for hand position, where you create a new hand position. So degrees is just a list of numbers representing different strings on the harp, right? And check this out. If len degrees is greater than 4, that's one of the situations in which you raise an error invalid hand position, right? If len set degrees does not equal len degrees, this means if you're repeating some note, so you shouldn't have multiple of the same string in a hand position. This is keeping all of the degrees actually on the harp, right? So not too high or too low. And then the last one is max degrees minus min degrees shouldn't be greater than 9. What's the max you can stretch?
The max is a 10th. That is a stretch, so it's not something we want to do consistently or repetitively.
Right, exactly. So I made it so anything bigger than either a 9th or a 10th, and I'm not 100% sure which one this is an invalid hand position, right? So to start with, there's some kind of validity checking to the hand position to make sure that whatever it is something that's kind of fits into the hand. Mm-hmm. And then the next thing that I've got here is this method called get hand position, which generates a hand position according to certain properties, right? So you give it the center degree, the number of strings, so number of fingers that you're using, the spread from the lowest to the highest string, and then I've also added evenness and bias. So if all the fingers are like this, right? That's both even and unbiased, right? Mm-hmm. If these 2 fingers are like this and these 2 fingers like that, then some of the fingers are really close together, some are far apart from one another. So that's an uneven hand position, right? But it's not biased because it's still kind of got a center of gravity down the middle. Do you see what I mean?
Right,
The same
that makes
at the
sense.
bottom and same amount up top. This is both uneven and biased. So the idea here was I wanted to be able to sort of shape what the position of the fingers in the middle was, so that it could be kind of, I could have it be more even or less even, and a little bit biased in this direction, less even and biased in this direction, right? And by the way, at this point, I still have no idea what I'm doing with it, right? This is the kind of funny thing about starting a piece of music this way is I didn't really know what the goal was musically. I just wanted the result to be something that felt good on the harp. And that was my in for this piece. The way I start pieces in Python really depends on the piece itself, right? Mm-hmm. And, in this case, the dominant thing was I'm working with you and I'm trying to write a harp piece that feels good for a harp player to play. And so this is how it starts. If I run this code, so I'm going to just say print hand position. So get hand position 10, 4, 8. So 10 is the center degree, 4 is the number of strings, 8 is the spread. So there's going to be 4 strings, spread of 8, and by default the evenness is 1 and the bias is 0. So let's take a look at that. So it prints out, as you can see, it prints out hand position 6, 8, 10, 14. So you can see these are relatively evenly spread, and they're as even as they can be. Distance of 3 here, and 2 here, but you can't actually make them all the same because the total is 8, right? So you can't divide 8 evenly into 3. But if I were to say something like bias equals 1, so if I say evenness of 0, then you can see now it's 6, 12, 13, 14. You've got them all bunched up at the top. Mm-hmm. One giant space between 6 and 12. Tell me, on the harp, if you bunch all the high notes together and have one low note stuck out, that would be awkward, right? That's
really awkward because what that does is it's forcing you to put a really big gap between fingers 3 and 4. So something like that is really uncomfortable. If you were to bunch the lower fingers together with a big gap at the top, that's perfectly fine because you have that natural gap.
Exactly. So if I were to say something like bias 0 or bias 0.2 or something like that, 6, 7, 8, 14. So that's much more doable, right? Maybe like the evenness 0.4. See what happens there. 6, 8, 9. There's a little skip there. So this is much more natural because you've got the thumb. So this is the reason I introduced the bias parameter, because I realized that exactly what the bias was mattered to the feasibility of playing the notes.
It's hugely important.
Now, whether or not I actually managed to get that into the music in the end, I can't remember. But that's basically what was going on here. And I had to write these like little functions to measure evenness and measure bias. And I guess I should add one more thing about hand position. Degrees to avoid. I added this at some point. Do you remember why I added this?
Would that have been to avoid repeating notes?
That was to avoid repeating notes.
Yeah, so what happens if you're repeating a note? With the motions of playing a note on the harp, you play the note, you have to come back on the note, pre-place it before you play it again. That pre-placing mutes the note. So if you're having to repeat a note in a pattern, it's not going to be completely legato, or it's going to sound different than all the other notes that you're not repeating. So it also gets
buzzy,
a little,
right?
It's potentially buzzy just because that note's ringing. It's also awkward because you do have to wait as long as possible to replace that note. So it gets a little dicey. It's not impossible, but it's not optimal to have that.
Yeah. So to me, as a composer, when I hear performers say, it's not impossible, but it's not optimal, what I hear is don't do it.
Or just don't do it all the time.
Right. And what I'm doing here is because I'm creating something systematically with code. If I don't say don't do it, it's probably going to start to happen systematically all the time. Because when you compose something by hand, you fix each individual issue one by one. When you compose it with code, often you are actually trying to write the code to systemically fix a certain kind of issue, or to systemically shape the music in some way or another. You know?
So that creates more consistency throughout the music, whether for better or worse.
That's a good point, actually. It creates consistency throughout the music for better or for worse. And sometimes consistency is worse, right? Because sometimes what we like about music are the moments that don't fit, right? That's what's often
Right.
interesting. But we do want consistency of not making awkward kind of strings that you have to replace the finger on. That's something we want to be consistent about, right?
Right. So it's really interesting to think about composing from this angle, because it's very opposite of, I mean, I'm not a composer, but it's very opposite of what I imagine that you all typically do. And that's why this is just so fascinating to me.
Well, should we take a look at the pedal code?
Yeah, let's take a look at the pedal code.
Okay, so here's the pedal situation. Maybe you can talk briefly about harp pedals?
Yeah, so the way that the pedals work on the harp, it's not for sustain like you would use on the piano. That's to give you your sharps and flats. So what happens is if you are trying to go from C natural to C sharp, you're going to be changing a pedal to get that change in pitch. And it happens all across the harp. So you can't isolate, one C to make it sharp and have another C flat. You can on a lever harp, but for a pedal harp, it's going to be changing all the C's on the harp. So it's important to keep track of those pedals just so you don't end up with, C natural, C sharp, which I do see, especially as we're moving into less tonal music. It gets a little tricky. So keeping track of the pedal positions and which pedals need to be changed at any given time is really important when it comes to writing for the harp.
Right, exactly. So because I was trying to build this in such a way that it would be idiomatic for the harp, I decided to model the pedal position so that at any given point in the piece, I always know what the pedal position is, right?
Mm-hmm.
And I'm picking notes from a hand position and a pedal position, right? Rather than saying I want a C sharp, it's going to be, I want this particular note within this hand position with the pedal set to this particular way. And so, so you can see here, well, this is an error. Hopefully you have to give it 7 numbers and they'll have to be either flat, neutral, or sharp. If you give it 8, there aren't 8 pedals for the harp. So that's a silly error. But anyway, so let's see what we've got here. I think one of the things that I was interested in with pedal position was kind of mapping out all of the different possibilities of pedal position.
Mm-hmm.
And I was trying to get a sense of what kind of qualities they all had. So this is a method that gives you all possible pedal positions. But then, some pedal positions have an interesting property that, if you do E sharps and F flats, like if you set all the E's to sharp position, all the F's to flat position, then if you did a glissando up the harp, it's not going to just go up and up and up and up. It's going to kind of turn around because F flat is actually a lower pitch than E sharp, right?
Right, which is a very unique element of the harp where you can actually get those, multiple strings that are the same pitch or actually change the order of the pitch direction.
Right, exactly. So I actually didn't make too much use of that except trying to avoid it in this piece for some reason. So this gives you a list of all the ascending pedal positions. So pedal positions in which each subsequent string is higher than the string before it. All non-descending positions means you can have a string which repeats the same note, but you can't have it go down. So you could have E sharp to F natural, which would repeat the same pitch, but you couldn't go E sharp to F flat. But then, you were mentioning something about the layout of the pedals in the harp. You want to talk about that real briefly?
Right. So the biggest reason that, a composer needs to understand this is because, some pedals are controlled by the left foot, some are controlled by the right foot. So if you're mapping out, what pedals you can change at any given time, you can change a right and a left pedal at the same time. It gets really dicey to change, 2 pedals on the same side of the harp. Some harpists can do it, but it's not really a norm, especially if they're not adjacent. So say, as you can see here on the screen, on the right pedals, you have E, F, G, and A. So changing E and G gets a little tricky. F and A, don't change those at the same time. So making sure that you're aware of, which pedals are controlled by which foot helps you know what pedals you can change at the same time.
Yeah, exactly. So I as I said, when you create it, I made it just go C, D, E, F, G, etc. But I built into the code that it has a knowledge of which are the left pedal positions and which are the right pedal positions. And I think if you go down here, you can see I've got a few other things here. So get adjacent positions. Always love a to-do that says make this efficient. But get adjacent pedal positions is basically saying, from whatever pedal position you're currently at, what are the pedal positions that you could get to in one change? Meaning, either a change on the right side, a change on the left side, or a change on both sides, but something that you could do in a single motion of changing the pedal.
Right.
That was something that I felt was important to build into the pedal class. Then the other thing is I even had a function called get distance, which is kind of trying to measure the distance between two different pedal positions, which is basically saying how many different actions of changing pedal is it going to take to get from this position to this position, right?
Right.
If I'm going to have to change 3 pedals on the right and 2 pedals on the left, that's a distance of 3, because I can change 1 on the left, 1 on the right, 1 on the left, 1 on the right. So those are 2 changes, and then I have to do 1 more change on the right.
Mm-hmm.
Does that make sense?
That does, yeah.
Okay. You know what? I even did path to. I can't remember if I used this or not, but I made it so that if you give it one pedal position and another pedal position, it tries to map a path from the first pedal position to the other one in terms of pedal changes. Anyway, got a little bit bonkers. I mean, the biggest thing that I used here is from a given pedal position, you can get what the pitches for that pedal position are. And also you can get the spelling of the notes from that pedal position, right? So here's the other thing that was interesting that I think I could have done more with, but in the end I wanted to actually finish writing a piece. But I tried to write a function that determined the harmonic tension inherent to a particular pedal position.
Interesting.
Anyway, the goal was to kind of almost be able to sort pedal positions by harmonic tension, so that I could, over the course of the piece, go up and down in tension or something like that. Is this too much detail?
No, this is fascinating. So we had talked about, how you created the parameters for the hand position and the pedal position. How did you go from that into developing a full piece?
Yeah. So in this particular case, I wanted to kind of build some sort of shape into the piece. You can kind of see here Google Trends in the background. Well, the reason that Google Trends is in the background here is I've experimented a little bit with making music out of just Google Trends data. I was just looking for a trend that was interesting. And so I tried a few different terms. So like if I do banana here, you can see this is what happens when people search banana over time. Like, okay, if that's not going to make a great piece of music, I mean, I guess it looks like maybe something really dramatic happened in November to 21st to 27th of 2021 as far as bananas are concerned. But, some other data, like if you do boots, I think is one of the ones I always kind of like. Searches for boots are very cyclical for an obvious reason. People care a lot more about boots in January and February, or November and January and February than they do in the middle of the summer, right? So this is a more interesting shape. But even so, maybe this is too cyclical. So I was playing around with different terms, and I came up with, I was thinking, well, what term would make sense for a harp piece? And I decided resonance might be an interesting one to use. So this, to me, I looked at this and I thought, well, that's a shape that you could make a piece of music out of, right? It's got these ups and downs. Sometimes it's up for a while, sometimes it's down for a little while. Part of the reason, for instance, that I was interested in making the hand positions not repeat notes is because I was trying to maximize the resonance of the harp, right? And so I thought, okay, resonance, I have it based on the word resonance, try to maximize the resonance of the harp. We'll call it resonance setting. So what I did here is you can kind of see in the code, resonance trend.csv here. This is what I downloaded from Google. You get these numbers which correspond to the trend going up and down. So what I did was, I loaded all of that. I stripped out all of the dates. I normalized it from a range to 0 to 1. And this was kind of the core shape that I was using to make the piece. And then the other thing was, from one of your videos, you were playing some bisbigliando on the harp.
Yeah. So bisbigliando, so it's essentially a trill tremolo. So usually on the piano, if you're doing a tremolo, you're going to be alternating groups of notes. And more of this type of motion. On the harp, it's actually going to be more arpeggiated. So if you're alternating 4 notes, it's like an arpeggio, but you just do it as fast as you can. And you'll hear that in the piece. But it's kind of like a cross between a tremolo and a trill.
So I knew I wanted to use that, but I also wanted to use some sort of cascading motion up and down the harp. So the kind of awkwardest, most difficult part of this was I kind of wanted to analyze this data so that stuff like this, where it's going way down very quickly, I wanted to have that be a cascading gesture on the harp, right?
Mm-hmm.
Where you're using several hand positions going, something like that. But then right here, where it's kind of staying in the same area for a while, I wanted that to be a kind of slowly evolving discretante. And so I wanted to split this data up into mostly stationary, moving now, moving back up. Okay, mostly stationary, moving now, mostly stationary, moving, stationary, moving. So that's what all of this code is here. It's something about, I guess, differences. So differences are looking at, like, how different is this point from the previous point? But then it's kind of jerky, so I smoothed it a little bit, and then I did some stuff that I probably will never remember again what I was doing. Is changing a lot is a great variable name. And you end up with some sort of partitioning between the parts which will be disgregando and the parts which will be kind of cascading up and down. So I did some stuff with that. Here we go, do cascade. So I made a function to do a kind of cascade down, up or down the harp, right? And I have do bisbig wandering, which is the kind of parts where it's kind of wandering around the same part of the harp in disgregando, but it's kind of changing pedal during that time. I decided to make all the pedal changes in the bisbig sections because under the assumption that it might be easier to change pedal while doing the disgregando than while doing a cascade up and down the harp actively.
Yeah, and that's accurate because it's easier to do a pedal changes if the harp is balanced and I'm kind of staying in the same position versus the balance is shifting if I'm going up and down on the harp, and that makes pedal changes a little, again, not impossible, but tricky.
Not impossible, but don't do it if you're a composer. Yeah. There's one other element to this which is maybe important, which is I have these patterns. So you can see up here in the cascade, 3U over 3. What was I talking about there? Oh, I know what it is. So what this is saying is that it's 3 notes going up, and you're dividing the beat in 3. This is kind of a little code I made for myself that I parsed. So 3U over 7, 4D over 7 means, okay, these are septuplet 16th notes. And it's going to be 3 notes going up, followed by 4 notes going down. Again, it's thinking in terms of hand positions. So the cascade is going to be a repeated pattern of 3 notes up, 4 notes down, 3 notes up, 4 notes down, 3 notes up, 4 notes down. Does this make sense?
Yeah, and I know exactly which section it is.
One of the things that you have to think about when you're making music from code like this is it's pretty easy to make kind of static textures. And then the question is, how does it evolve over time? Because it turns out that when people listen to music, they actually want to hear it change.
Mm-hmm.
And so this shape I thought was quite interesting, but it's locally interesting, right? But it's not globally interesting. Like, if you play through this, you're not in that different of a place at the end than you were at the beginning.
Right.
You know what I mean? So there's no broader shape to that. So one of the things I did was to make it change over time. I decided to make the patterns for all of the cascades up and down the harp to go from kind of faster notes, sort of hand positions of 4 and 4, then 3 and 4, then 3 and 3, then 3 and 2, then 2 and 2. By the end, it's 16th notes instead of 32nd notes. And you really hear that in the piece, this kind of gradual dissipation of energy, right? The cascade.
Just, drawing out.
Right. So that was something I did to kind of shape it over time.
What factors were you trying to control in the piece versus which ones kind of just happened? What kinds of things were you surprised at when you built the piece?
Okay. The only thing that's randomly generated over the whole piece is the spread and bias of the hand positions. So I wanted there to be some variety in the spread and the bias. And actually, kind of interestingly, look, this is random.random 0.5. So that's the bias. And so I'm randomizing the bias, but only low bias, right? So it's not ranging from 0 to 1, it's ranging from 0 to 0.5 because I didn't want to end up with any of those awkward hand positions that you told me about, where all the fingers are bunched up near the thumb. But other than that, everything is, technically speaking, deterministic, right? I'm not using randomness. That said, how deterministic is this really, right? Like, this isn't a predictable shape, right? I picked something that was kind of unpredictable. And part of the reason for that is the reason for doing something with code, the reason for writing music with code is to find happy accidents. right? To find just like, oh, if I throw these different elements together and I see what it spits out, it turns out it's kind of interesting right there for some reason. I don't know why, you know? Now, part of the idea with Scamp is that I'm writing the code and immediately I get oral feedback from it. So right here, if I run Harp demo 5, I don't know, did you ever hear this? This is what it sounded like on my own.
No, I haven't heard this.
I mean, this is, of course, this is the finished piece, right? Barring some little tweaking I did after I exported the notation. One of the surprises I kind of liked was just the variability in how long the BizBig sections last. So sometimes it's just a little bit, and sometimes you're in there for a fairly long time.
Right.
What's your favorite moment in the piece?
My favorite moment is in one of the cascades. It's on like page 3, where you're shifting in the cascade section from the groupings of 6 to the groupings of 5. And it's like, it's a really dramatic moment. You're like, you know, going up and then you shift and then you start to go back down. It's like, it's the climax of it. Because I think I emailed you right away. I was like, I love this moment here.
We had a little discussion about that moment because that was an accident. It was totally an accident. I didn't even realize that I built the code in such a way that that was possible. You know, the code kind of alternates between cascading up and down and these, you know, Bisbiliando sections. And I didn't think that within the cascade, it should be able to change from a pattern of like, you know, 6 to a pattern of 5. But the point is that that was actually independently also my favorite moment. And it was the moment that was least planned, right? So that goes a little bit towards what you were saying earlier about, you know, working on code, you're kind of working on systematically, what does the music sound like overall? But it turns out that like one of the big things is, well, there's one moment where that broke turns out to be the best part. So like, you know, why is that? That's the kind of like unpredictability that I get excited about with computer music. You know,
it's like you control so many elements of it that there's little surprises that slip through that you wouldn't have expected to even be there.
Yeah, and if this was a longer collaboration, I were writing like a 10-minute piece or something like that, I might take that moment and say, maybe I should make that more prominent. You know, maybe that's a bigger part of the piece as a whole. Definitely part of the process of working with code and making music through code. And part of the reason I built Scamp to give you, as you've heard, like immediate auditory feedback is you write the code and it does something unexpected. And then if you hear something unexpected that you like, you can reshape the code to kind of move more in the direction of that. And you're kind of like sniffing your way towards a piece, which is interesting. You know? So one of the things I was very curious about was what was the most technically challenging aspect of working on this piece? Because I put so much energy into trying to model hand positions and pedal and stuff like that so that it would feel natural for the harp. What ended up still being difficult?
So I will say, without a doubt, the most difficult section was the cascading sections. And the reason for that is because, as you can see on the page, the patterns are changing a little bit each time. So when I play that first group, ended up playing with the first 4 notes with the left hand, next groups with the right hand. You can see those shapes are a little bit different. And then if you compare the first left hand group with the second left hand group, the shapes are also a little bit different. So trying to learn those shapes and be able to land on those notes correctly was probably the most difficult part. The Bisbiliando section, since it was a little bit more static, that was a lot easier. So literally, I was learning through this piece. I would just practice first cascade, second cascade, third cascade.
It's actually, I wanted to point out one other thing about that, just kind of almost as a warning to composers who are writing music in this way, using code, which is that randomness adds variety for sure, but it really adds technical difficulty for performers. Like, oftentimes it really does. I've noticed this not just in this collaboration, but in many cases, when I've written something that involved randomness and I give it to a performer, you can see that they're struggling with the fact that the patterns are constantly changing. And I'm struck by the fact that what you're saying is the most difficult part. We looked at the code a moment ago, And that was the one time I used randomness in the piece. That's where the calls to the random library was in the shape of the hand position.
Which is interesting because you do also have to have some level of not patterns. Otherwise, a piece is going to be really boring if you're doing the exact same thing. Same patterns over and over. It doesn't give you enough texture. So.
Oh yeah, and that's why we're drawn to randomness.
Yeah, you need both. You need the patterns, and you have that pattern in the piece. So for the listener, they can hear cascade, static, cascade. So there's enough of a structure to it to make sense of the randomness. And I think as the performer, there was enough of the structure there.
Yeah, and I was having a conversation with a student fairly recently about the role of randomness in composing using computers, or just in general, like what's the value of randomness and what are the pitfalls of randomness? Because I mean, the pitfalls are kind of obvious. Like humans are we are big into patterns and stories, and patterns and stories are not random, right? They're kind of by definition not random. A lot of
patterns and stories seem like the most difficult element to introduce into computer code.
Totally. I mean, maybe that's why I took a Google trend or something, was I was like, maybe there's a story embedded in this, But it's true. It's true. Well, patterns you can embed in code pretty easily, but stories, that's hard. But yeah, I don't know, the way that we approach the world, we're just like story making machines. We take totally random noise and we make stories out of it all the time. It's one of our kind of pitfalls in interpreting the world sometimes, but also kind of a beautiful thing about human beings. But yeah, so there's pitfalls of randomness, but one of the benefits of randomness is that sometimes it helps you to explore a space of possibilities, right? When you write music by hand, you tend to move towards these gestures that you've done this many times before. And when you incorporate randomness, you're kind of shocked into the spaces that you don't naturally go into. And that, for me, is one of the reasons to use code to make music, is to have the code take me to places I wouldn't otherwise go. Randomness is one way of doing that. But
that makes a lot of sense.
Yeah. But you have to be sensitive to the fact that can make it hard on your performers. And I'm kind of struck by the fact that this moment of introducing randomness is the thing that made it hard.
Well, if it wasn't this, it would have been something else.
Yeah, fair enough. And hard's not necessarily bad, right?
No. I mean, it means taking longer to learn a piece, limits how many pieces I can learn at once type of thing, but...
Actually, I'm curious if you can just really quick speak to, is there good hard and bad hard?
Good hard, I think, has enough understanding of idiomatic writing so that it challenges it without just blowing past those boundaries. Hard idiomatic might not even be hard music in the sense that it doesn't really take into consideration idiomaticism. So that's kind of how I distinguish. And I can tell there's usually a very strong difference, especially in that music that is not idiomatic. It's often not even intended to be hard, but it ends up being almost impossible. Whereas the music that's more carefully constructed in regards to idiomatic writing, but tries to push those boundaries, it feels a lot more doable. And that once I've learned it, it feels comfortable, and that I can actually play it, express it, rather than music that I'm always going to be struggling to keep my fingers on the strings playing through the piece.
I guess there's one more question that I have, which may be a good kind of wrap-up question. How was this collaboration for you similar to or different from collaborations with other composers that you've done?
All the collaborations I do are often so different, just because, composers write differently. They have different things that they're trying to explore, different influences. And that's one of the things I love so much about working with composers, is that nothing's ever the same. So the one thing I thought was kind of cool about it is that a lot of times composers write music by hand, but then have it performed by computer instruments, whether using sample libraries, MIDI, whatnot. This kind of flipped it on its head. We wrote the piece using a computer, but then had a live performance. So we brought back that human element to it. So I thought that was kind of a cool way to experience it.
And for me, I mean, part of the reason I reached out to you, part of the reason I'm trying to do these collaborations with performers is because I want that, right? You heard the sound of the computer playing back the music. It's interesting. You can get a sense of it. It's a good kind of facsimile of kind of what the piece is. But there's so many little details that you get when a performer gets into the piece, and there's just no substitute for that.
Right. Oh, people struggle to try to do that with, trying to really control the dynamics and the tempo. But it's really tough to be able to bring that human element into something that you're performing via a computer.
One thing you said earlier that I was struck by was you said you realized that maybe there was enough detail that it didn't actually need to be so fast.
Mm-hmm.
Almost every piece that I write, either in like MuseScore, Sibelius, or something like that, or using Python code, when I'm getting the computer playback, I always set the tempo too fast. Every single time the tempo is like 20% faster than it should be. And then when a performer tries to play it, there's just no space to breathe at that tempo. And they slow it down 20% or whatever. And it still has probably more life than it had on the computer 20% faster. Because the reason you always turn up the tempo when you're working on the computer is you're trying to compensate for the fact that it's a little bit dead.
Right.
Give it some life by speeding it up. But a different way of giving music life is to give it to a performer and let them actually bring a kind of human interpretation to it. So
that makes so much sense. I never really thought of it that way, because sometimes I will ask the composer for the MIDI, especially if it's really complicated rhythm, just so I can kind of get it in my ear what they're envisioning. And I'm like, the tempo is always faster than what ends up being possible. And I always feel bad about it, but that does make a lot of sense that sometimes it's easier on your ear to listen to it faster when you're using the MIDI playback. I say this as someone who listens to podcasts at 2x speed, so there's probably...
Oh yeah, I max out at like 1.5x speed, but I know. Hey, well, thank you so much. I mean, this has been an amazing collaboration for me. I learned a lot about the harp and really enjoyed the performance of the piece.
Oh, thank you. This was a lot of fun.
Oh my goodness, thanks for making it all the way to the end of that whole video. We'll end with the full performance of Resonance Study for solo harp, performed by Danielle Kuntz.